Okay, this is lesson 4.9, which is elimination, and I'm just going to do the right-hand column of the presentation. Okay, so to solve a system of equation using elimination, what we want to look for is two variables that if I were to just add them straight down, they would cancel out. So for example, the x terms, this would become 5x. But this right here, this is a positive 1y minus 1y, which equals 0. And so when we add these straight down, this is 5x, this becomes 0, and this is 25. We have now eliminated the y term to just solve for x. So the x coordinate of my solution is 5. Then I take this x equals 5 and I substitute it into either one. I'm going to choose the first equation. Everywhere that I see an x, I'm going to substitute 5. So this is 10 plus y equals 9. Subtract 10 on both sides. Y equals a negative 1. See how simple that was? That was solving systems using elimination. So let's go ahead and do one more. Another one, very similar. Looking at this system, right? If we were to add straight down, this would be 1x plus 1x, which is 2x. Negative 2y plus 3y, which is going to be a positive 1y. So neither one is going to get eliminated. But what if we just took one of the equations, let's say this one, and we multiplied it by negative 1? If I multiplied every single term by negative 1, this would become a negative 1x, which would be negative 1x plus x, which is 0. So I'll multiply every term by negative 1. This will become a negative 1x. Negative 2y times a negative 1 is a positive 2y. Negative 9 times a negative 1 is a positive 9. I'll rewrite this equation because I'm not doing anything to it. And I'll add them straight down. Negative 1x plus x, 0. 2y plus 3y, 5y. 9 plus 16, 25. I've now isolated y to be 5. Take this, substitute it back into either equation. I'll choose the second. Y equals 5. Everywhere that I see a y, I'm going to substitute a 5. And then to isolate x, I need to subtract 15 on both sides. X equals 1. My solution is 1, 5. Again, solving systems by elimination. However, things are sometimes not that straightforward. If we take a look at this system, I see I would add straight down. This would be 5x. This would be positive 3y, so neither one would get eliminated. But just looking at it, I'd have to do a lot of work in order to get these to cancel. But right here, this is a negative 1y plus 4y. If this was a 4y, be minus 4y plus 4y, which is 0. So I'm going to multiply this first equation by 4 so that this would become negative 4y. So let's go ahead and rewrite. 2x times 4 is 8x. Negative 1y times 4 is a negative 4y. 9 times 4, which is 36. I'm going to rewrite the second equation. And add straight down. 8x plus 3x is 11x. Negative 4y plus 4y, 0. 36 minus 14, 22. Divide both sides by 11. x equals 2. Take the 2, substitute it back into either equation. I'll choose the first one. Substitute everywhere that I see an x. I'm going to substitute a 2. Minus 4 on both sides. Now I have negative y equals 5. Am I done? No. I need to divide by a negative 1. Y equals a negative 5. So the solution, 2, negative 5.